Well, hello again everyone, and welcome back to the radio shop. I have here on the bench today a piece of equipment made by Sencore. It's called the CB42, and just how it says, it is a service monitor that was designed for the CB service back in the 70s and 80s when CB was a big hot thing back then. In fact, several companies made equipment just for servicing CB radios, and Sencore made some pretty decent equipment back then. You know, they made this signal generator and monitor, and he also made a CS61 oscilloscope that was worked well with CB radio repair because it had a built-in frequency counter and voltmeter in it. So it just, you know, teamed up with this piece and the scope. You had pretty much everything you needed for working on a CB radio. Now, I've said many times before in some of my previous videos, if you want to get into radio RF related electronics and you're just starting out and just starting learning electronics, or if you even already got a good grasp on electronics and would like to get into the field, you know, again, before you jump on the radio like the Yaesu 2800M that we just repaired in the previous video, you want to understand how RF electronic works before you jump on something like that. And by doing so, you know, CB is a good platform to start on. First of all, you can get them for next to nothing. I mean, I haven't been to a flea market or yard sale where I couldn't buy one for a couple of bucks. You can carry it home, download the schematic, service information, and go to town and learn all sorts of things working on a CB radio. You know, you can pick up one that's tube type or solid state. You can pick up, you know, a plain AM rig or one with single sideband. So, you know, that gives you the basic platform for working on ham radios. Just because, you know, we know a lot of people knock CB, but for what they are, you know, it's what it is. It's a good learning platform. And instead of jumping into a several $100 radio and end up messing it up because, you know, you don't know what you're doing, if you mess up the CB, you're only out of a few bucks. But anyway, you know, me and Mike has discussed this several times, but I get lots and lots of emails asking what type of test equipment should I get. You know, what type of test equipment do I need for my shop? I want to learn how to work on radio. I want to learn how to work on ham radio. Well, you know, before test equipment comes, knowledge comes. And that can take a while to do. But, you know, if you go online, there's a lot of great tutorials on YouTube here on radio repair, and, you know, a lot of good names out there that, you know, can teach you a lot of things. And they're mostly in my suggested list here on YouTube. But if you go out and buy a piece of equipment and it doesn't work, you know, do you have the knowledge to fix it? Now, if you're only going to work on CBs, this CB42 is a great piece of equipment. And if you have the knowledge, you can buy one cheap like this guy did. This one belongs to a friend of mine. He bought it and had a price, you know, and best offer. Well, he submitted the best offers. I think he said it was $125. Now, I have seen these go as high as 300 bucks on eBay. But he purchased this one for $125. Now, that throws a red flag for me. Whenever you see a piece of equipment like this, and you see how nice and clean it looks. You look up there in the corner, you see mine sitting up there. Let me move this swing arm out of the way. Now mine is came from a shop that everybody smoked in, and It's all yellow and it doesn't work anymore. And one day I'm going to get to it and repair it. Not that I'll be using it, but just so I have the piece of equipment fixed. And beside it's the B&K 2040. Now, unlike the CB42, it's a self-contained unit. The B&K 2040, you need two pieces. You also need the 1040 to test the transmitter. The 2040 only tests the receiver. The CB42 has it both built in. But I wouldn't suggest, if you're going to work on ham radio, not to go out and buy this unit, because like I say, this only covers the CB band. Go out and get you something like an HP 8640B. Great stable piece of equipment. They're easy to work on and they will do a good job. I would almost even say, if you're going to just work on CB, I would suggest buying that over one of these. Now, you will pay a higher price on the 8640B than you probably would on this Sencore unit. But anyway, he bought the unit, got it in, and sure enough, it has problems. So let's hook this thing up and take a look at it and just check it out and see what is working on it. Okay, so the first thing we'll do is make sure the unit off. We'll set everything to where it's supposed to be to start with, and we'll go ahead and plug the power in and turn the unit on. And I see part of the error right to start with. If you look at the LED display, well, first let me tell you, we're on RF AM, we're on CB channel 20, and our megahertz light is not lit up, but our kilohertz light is, and we are reading the wrong information on the display. So as I turn the selector, I am getting some activity going on up there, so that's telling me that some of the circuit is working. It's just not working correctly. So I put it back in RF IF generator. Now this unit will generate the 40 CB channel frequencies, and you do have an output selector and modulation selector. It will also put out from 375 Hertz to 12 megahertz. So if you needed to generate an IF frequency to replace a missing IF in a radio, and it is tunable across that whole band. But the first thing we're seeing is no display, or no information or usable information on the display. So I'm going to turn the microvolts all the way down. I have a CB radio here on the bench. We'll connect it to RF IF out. The radio is set to channel 20, and I'll turn the microvolts up. And as you can see on the radio, we have a full scale on the needle. I'll turn the modulation on. I'm switching between 30 and 100. I have it at 1000 Hertz, and there is nothing at all coming out of the speaker of the radio. Now this is interesting. You heard that tone, so we'll zoom back in here to the audio knob, and you can see we have all 400 hertz, 1000 hertz, and single sideband tone, which is a 500 hertz and 2400 hertz tone that's mixed together for single sideband. I hear nothing in the 400 and 1000 hertz tone selection. I do have a tone when I go to single sideband test. So we already know there's also a problem in the audio amplifier. But it's kind of strange that, you know, you're not hearing it in it's working in single sideband, but it doesn't work it in the other two test tones. Interesting. What could have caused this problem? Well, when you're working on the radio, you have your audio output jack here, and you have your speaker sub here, and what you can do is tie your speaker input into this jack and read SINAD. Well, it's probably somebody has put the wrong single or a lot of voltage back into this and have took something out in the circuit. Now, why the display don't work, that's another mystery. But we know that RF generator is working on channel 20. Now I'll go to 21, and we can hear the radio is going to making hash. We go back to 20. I'll bring it all the way down to channel 1, because what we want to make sure is that the PLL, and we have full output. We'll go to channel 40. And we have full output. So this is telling me that the generator is working, which means the PLL is good and stable and is locked and not running free. Now mine, the PLL is running free, and it puts out one frequency down in the low 26 megahertz band, and will not lock on the regular CV bands. But one day I'll take a look at it and maybe we'll get a little learning off of it. So I guess now we see that, you know, we can't test any of these other functions. You know, the crystal test, it does have a frequency counter, 1 meg input in it. You know, you can plug a crystal in and check the it has an oscillator here, and it'll check from 1 to 20 megahertz fundamental frequency. It shows percentage off channel, which means you key up the radio into the unit and it'll show you if it's directly on. It's like 27205 and tell you how much it's off. It does positive and negative modulation. It shows you RF watts and also audio watts, and it also generates a noise. Interesting. As I'm pushing this button, I'm seeing the megahertz light flash, so something's funky going on in there. But anyway, let's go ahead and pull the covers off of this, and we'll take a look inside. And I'm not going to do a full repair on this just yet. Only thing I think I'm going to focus on right this minute is the audio output section and get that taken care of and see what's, you know, causing that problem. Then we can move on later on to the digital board and the function board and find out what's going on with the display. So to get this thing apart, we have 2 screws here in the top, have 2 on the side, and I think there's 6 underneath and 1 in the back. So I'll go ahead and get those removed and we'll take a look at it. I got the unit apart, but before we get into that, we'll take a look at this manual here. I have the original CB42 manual, and not only is it the service manual, is also, you know, goes in and tells you how to use the system. And then back here in the back, It starts here with maintenance and service, and it gives you a outline of a block diagram, and goes on to tell you you know, how to adjust everything. Also with it, they give you these fold outs. Like this unit is sheet 2, and it shows the block diagram of the CB. Sencore 42 has boards layouts, and then when you open it up, it'll have different schematics and stuff. Now, there's a legend here, and these are supposed to be color coded. So I don't know if this is not the original and someone copied it, so it didn't get a cover, you know, color overlay on it, or just what it was. Now I do have a another set here. I'll show you in just a second. You see, this one's the same way. It shows boards J and E. Tells you how it works. And this is going to be the schematic we're going to look at, because if you look right here, I can already see on this one, it's this audio output. So this is the circuit that we're going to look at for the audio problem. So I'll set this aside, and we'll be looking at this in just a minute after we have a little look over the unit. Now, let's see, as I said, I had some color. Paperwork here, and this is something I ordered many years ago, and you can see the block or the color legend here, and then it's, you know, you can see it throughout the schematics. So they come in very, very handy when you're tracing signals through this. Now, out of all this information I have, there is one bit of information that I do not have with this, and the schematics and the block diagram doesn't really show you this, and that is the circuit description or theory of operation. Now, back in the day when this was printed, there's a note here, complete circuit description. Says you know, it can be ordered for $5, and that is the only thing I do not have for the Sencore CB42. Now, if anybody has a copy of that circuit description, I'm more than willing to buy a copy from you. I talked with Sencore many years ago, and they no longer had it available. At the time, they did have the schematics for this available, but they did not have that circuit description, and I have not been able to find it in the past 10 years. So if there's anybody out there that does have that circuit description, I would love to get a copy of it. So we're looking here at the back of the unit with the cover off of it, and you can see here is our channel selector. It's basically the same thing that you would find in a CB radio. LED board. This is the counter unit, and below this is the function unit. Now over here in this big cage is our PLL unit. So one of the first things that you have to look at when you're working on one of these, we already know that the display is not working correctly, but we should be getting a signal from this RCA jack that comes over and feeds into the counter board, and as you change channels, this changes frequencies and tells the counter board what frequency you're on. It interprets it and puts it on the display. But since none of the other functions is working, it's probably something going on with the clock. Now, as you know, there's a lot of TTL logic stuff going on this, and one of the main things you have to look for in TTL and logic stuff is power supply voltages. and the health of that voltage. And you see here on the back we have 3 wires: red, black, and yellow. The red wire is 10 volts, the black is ground, and the yellow is your 5 volts. And this is DC, so it basically runs on 10 and 5 volts circuits. And the ripple must be very, very low on this, or these digital circuits will go crazy. I went ahead and removed the shield from the PLL unit, and what we want to do is just confirm that the signal is coming over to the board. So we're going to take our scope probe and we're going to clamp right onto the bottom of this RCA connector. And then we'll have a look at our scope. And we can see that it is putting out a 6.75133 megahertz. Okay, I've removed the shielding here, and I've got the unit on channel 20, and I've hooked our scope probe up to the bottom of this RCA jack that feeds that signal over to the counter board. And we'll take a look at our scope here. And I can see that we are putting out the 6 megahertz signal. In fact, this reading 6.80133 megahertz. And if I change the channel selector, it's now putting out 6.77883 megahertz. And that's 6.76383 megahertz. So our signal coming from our PLL unit is working correctly. So no problems there whatsoever. It's really funny because most of them, these that I see, it's the PLL unit that has gone out and not the counter and function unit. So this one's a little backwards from most. Now that we're not going to get into the PLL unit that much, but we'll just get a little quick look at it here. We can see our 10 megahertz reference crystal here, and it uses the CD4059 PLL chip, as you can see right there by the front under this capacitor, or beside this capacitor. And you won't find too much information on the internet about this, but to help you, I do have something that a friend of mine sent me. And what we have here is the PLL system block diagram for the Sencore CB42. Now this was designed by a friend of mine. He's on my website, Lazarus, that had put this together for me. He's real good at doing this kind of stuff, especially when it comes to PLL stuff. And he can take a circuit and go through the schematic and pretty much you know, tell you what's going on in it. But I'll leave a I will post this on my website for download in case anybody needs it. He's completely happy with me doing this, so you know, make sure to give him the credit for it. So if anybody's looking for the a block diagram of the PLL, here it is, and it'll give you the it shows you, you know, starting with the reference oscillator 10 megahertz, going into a divide by 10 decade counter, 1 megahertz square wave out, into a dual flip-flop divides by 2, 500 hertz out, 5000 hertz out, into a level converter, and right on through the whole system. but I will leave a link down below. And you see here with the this is set to channel 1, that's all 26.965 megahertz signal out. But I'll leave a copy of this on the website and a link to it for download. So what we want to look at today is why the tone generator is not working correctly. And it's going to be in this section here. Now our switch that switches to tones is on the function board, which is here in the bottom. I believe this is board J. So this is pretty much what we're going to be looking for. So I'm going to pull the schematic out for board J and we'll take a look at it. Okay, so here we have the schematic for the function board, because this is where we need to look at. And I had mentioned that the audio tone adjust switch was on the function board, which is located right here. Now if we look here on the schematic, we'll see that our audio output from the unit comes in, goes through these audio output transistors, through our audio adjustment part on the front to set the level, and then it comes right on back down into the switch down here. So we already test that the single sideband tone is working, the dual tones. As you can see, we have an op amp here, the LM324, and you have one section of it for the 2400 hertz and one section for the 500 hertz. So this section is good. We know that that's working. Now you have to excuse this schematic. Whoever made it didn't quite get the width of it right, so we're missing just a little bit right here in the middle, and that's why I've never taped them together. But you know, I do have the full black and white copies, so if there's anything here I was questioning, I could go back to them. But you know, it's easy enough to look at to see where the lines are going to. So here we have another LM324, which is IC908, which is going to be IC8 on the board. I use a 90 designator. But when we look at the switch here, this is the off position. This is 400 hertz. That's 1000 hertz, and that's a single sideband tones. So when we look, we know that the 400 and the 1000 does not work. And as we follow these up, you can see it comes from pin 8 of the LM324, and the 400 hertz comes from pin 7 of the LM324. So we have to wonder, you know, is the problem in this section here, since there is no output at all on the 400 and the 1000 hertz. So what we need to do is locate this IC and have a peek at it. So this is the board layout. This is the component side. What we need to do is find IC8, which is here. So this is the one that's going to be in question as to why we're getting no tone out. So now that we know where it's located on the board, we can go in and find it on the function board. And to show you exactly where it's at, this is one reason why I did not put the shield back on the PLL unit, and so we can get through this IC and test it without having to pull everything apart. And if you look right down here, you can see this IC, it's LM324, and this is IC8. And looking at the rest of the chips on the board and looking at this chip, there is something I already see here. Somebody has socketed this chip. You see this white socket underneath of it. So somebody has already looked at this area, and you can see that it looks like there's been some new capacitors replaced here. So to me, someone has already, you know, been working on this thing, trying to find out what was going on, and apparently failed and gave up on it and decided to go ahead and pass the unit on down. So we need to take a peek at that chip and see what we see going on with it. So what I'm going to do is put it into 1000 hertz mode, and I'm going to come here and I'm going to probe this IC and see if we're getting any signal at all from it. Pin 14, there should be a 1 kilohertz signal coming out of pin 14, and we need to check and see if there's anything going on here and see what we can find. So I'm going to go ahead and like I said, this is why I wanted to leave the PLL shield off, so I can get in there and probe this chip. Now that's real strange. This is our input, and you can see something is trying to happen on the input of this chip. But when I go to the output, nothing at all. Yeah, that's real flaky. Alright, back to the output. Nothing. Alright, the next thing I want to do is go ahead and see if we do have the correct voltage on that chip. So we're going to take a look at that, and we should have 10 volts. And we have exactly 10.07 volts on the chip. So that the voltage looks good. So my conclusion on this, I mean, without doing any other testing, is either we have a short on the output of this op amp, or the op amp itself is bad. And looking at that waveform on the input, it really makes me think something is going on inside the op amp. So what I'm going to do, I'm going to go ahead and pull this op amp out. Alright, I have the chip out, and what I'm going to go ahead and do is probe the output and see if it shows any continuity to ground, or see what the ohm meter will show. And we'll go to ground, and we'll go to the output of the op amp. And I am seeing nothing. I'll change the meter leads around. Plug into the output, and still nothing. So at this time, I'm thinking that this LM324 is bad. Now looking at this, I think this is 86, and the date code is matching the rest of the codes on the other ICs that's in here, and it's the same brand, so it almost looks like this is the original IC that was pulled and someone put a socket in it. And what we're going to do is grab some old new stock that I have. This is LM324 from Radio Shack, and we'll get that popped in and see what it does. So, you know, I'm not going to get into telling you how op amps and stuff, or how the circuit and stuff works. If you want to learn more about op amps, there's lots of tutorials on YouTube. Dave has quite a few on op amps and over at the EEV blog. So, you know, you can go over there and look and find out. A lot of times you can pull the data sheet and you can look at it, and even the package here on this Radio Shack one has your most of your specifications and your diagram on the back to tell you how they work. So yeah, you know, a lot of this stuff you can call it homework. You can go out and do yourself and read up on it and figure out, you know, how op amps work. Okay, I got the new LM324 replaced. I'm ready to sit here for a minute and check to make sure it wasn't getting hot, and it seems fine. Voltage looks good on it. So the next thing is, do we have any audio output? Audio output's wide open. We'll go to 400 Hertz and we have a tone. 1000 Hertz, single sideband. Okay, so the audio output section is now working. The only thing that sounds like to me that 1000 Hertz tone is a little higher than what it should be. 400 sounds somewhere close. 1000 does not sound like it's correct. So that'll be part of the alignment. And this is all I'm going to have time for on this today. I'm going to go ahead and get with the owner and see if he wants me to order the caps to recap this thing with, or if he wants to go ahead and order them himself. And I'm pretty sure that we're going to find more of those op amps in this thing that's bad, and see if he wants to go ahead and order a bag of them. Usually that's the best way to do, is go ahead and order that. But as you see, it's not that hard to go in and figure out simple little circuits. You know, look at where the signal is coming from, go there, and most of the time that is where you'll find your problem. Now if you'd like to see more of this repair, you know, let me know by leaving your comments down below, and we'll get into working on this counter if you'd like to see that in the near future. And go ahead and can't we get it straightened out and get it working, then do a complete alignment of this thing. I don't think there's one on YouTube as far as a repair video at all. At least I haven't seen anything on YouTube on this model. So if you're interested, leave your comments down below, and you know, if there's enough response, we'll look at doing videos on rest of the repair. We got quite a bit here in the shop to do, so you know, it's going to be one of these off and on things, a little bit here and a little bit there. Anyway, we'll end the video here, and I'll go ahead and get back up with the owner and see what he wants to do. Anyway, we'll catch you in the next video. Bye now.